This is the long answer question number 4 with 9 marks. A coconut falls from a tree. So let's say this is my coconut tree and there is my coconut. And it's 44.1 meters above a deep tank of water. There's my tank of water. The coconut falls 44.1 and it's going to have constant acceleration of 9.8 meters per second squared. And since that's positive, we're considering going down as being the positive direction. After the coconut hits the water, it is subject to an acceleration given by this. This is after it hits the water. Okay, so the initial, because I have constant acceleration, I can use v squared equals u squared plus 2as. I know the distance, 44.1. I know the acceleration, 9.8. Therefore, take the square root of that and I get 29.4, exactly what I was after. Now, I know that this was a show that question, so this 29.4 is going to get used. Remember, v equals 29.4 when it hits the water. Otherwise, why did they make it a show that if they didn't want me to use it in the next part? Okay, so that's the first bit. The coconut's fallen to the water. Now when it hits the water, it's going to sink, then rise to the surface. So when it's in the water, show the velocity of the coconut in the water as a function of time is given by this rule. Well, when it's in the water, it's under this acceleration, and the acceleration is now varying. I can't use these rules anymore because the acceleration is varying. So it's a show that. So it's a little bit of set it up, use your calculator at the same time. So I've got my replacement for A, I'm going to use dv to t, because this is in terms of v and t. And to get the v on the bottom, to put the dv over here, I flipped everything upside down. I've then thrown this on the calculator to get an answer, and I have plus c. I use my v equals 29.4 when t equals 0. Now I'm going to say t equals 0 because I'm going to recalibrate that the coconut falling to the water, I'm going to recalibrate x equals 0 and t equals 0 here again, and then rework out from this being when it goes into the water. And I found out my C is 1 on 30, then I do this. On my calculator, I got an expression that had numerator and denominator, so I did a fraction poly a prop frac, and it gave me exactly this. But don't write anywhere on here that you used your calculator. Okay, so that's, I was able to get 3 marks for that. Then the next part of the question says, if I can find it, how long after falling from the tree does the coconut float back to the surface of the water? So I've got 3 bits of time. I've got when the coconut falls from the tree, and I've gone back up over here and I've said, okay, I'm going to use S equals UT plus a half AT squared, because I want to find out the time. S is 44.1, A is 9.8, I can solve for T, and T is 3. So I know that the first part is 3 seconds. Then it sinks to the bottom, and it will sink to the bottom. I know when we'll get to the bottom, because we'll get to the bottom when the velocity is 0. So I set this equal to 0, and I solve for T, and I know that's 49 on 12. So that's 49 on 12 seconds. So 3 seconds for it to fall from the tree to the water, 49 on 12 for it to sink to the bottom. Now, I have this rule, which is a V with respect to T, Therefore, that's dx dt equals 30 on 2t plus 1 minus 3/5. That's a rate of change graph, and with my rate of change, the area under the curve from 0 to 49 on 12 will be the distance travelled. So I've integrated that expression from 0 to 49 on 12 to get 7.33. So as it sinks a distance of 7.33. So to find out when it's going to get back up to the top, I've integrated the same expression from time 49 on 12 up to b, the time it gets to the top, and I've made that distance equal to negative 7.33 to find an answer of 23.5275. Now, why did I make it equal to negative? Well, I'm saying everything going down is positive, therefore when it rises I'm going to have a distance of negative 7.33, remembering that my curve is now going to be below, and I'm wanting that area to be negative 7.33, because when it's negative 0.733, the coconut will have risen back to the water surface. So I ended up with an answer of 49 on 12, 23.5275 minus 49 on 12, the 26.5275 is the time it takes for the coconut to fall, sink, and then rise to the surface.